Subscribe to Amcode and ring the notification bell to get the latest content.
Okay, so let's start with what is PySpark. So basically, as the name suggests, PySpark is nothing but a Python API which is used for Apache Spark. So this is a high-level API over Apache Spark which gives you the capability to work with Python language, which is favorite for everyone, I think. So it enables you to perform real-time analytics as well as the large scale of data processing which Spark is already known for in a distributed environment using the Python language. So since Python is pretty easyable and easy to understand for beginner level developer as well, it gives us the capability to work with Python language and build the applications which are similar in terms of performance as well as the optimization if we write the similar code in Scala. So that is why PySpark is widely used in the data community right now. So as you can see, this is the high level architecture of Apache Spark. It has the RDD, which is resilient distributed dataset at its core, and it is also known as the Spark core. And on top of the Spark core, we have like different APIs which serves the different purposes. And at one side we have the Spark SQL and the data frames, which gives us the capability to submit simple SQL queries using Spark SQL, as well as we can build data frame on the structured data seamlessly, and it is very simple to understand. So PySpark will also support this PySpark SQL as well as the data frame APIs of Apache Spark. So you can able to process structured data very seamlessly. And on the other side, we also have like Pandas API on Spark, which will give us to integrate Pandas library with Apache Spark using Python. So if you already know about Pandas, Pandas is similar to PySpark in many cases. It's just that it is more suitable for smaller dataset and it only runs on a single cluster, which is nothing but your local system. So next thing, on the other hand, we have the structured streaming. So PySpark will give you the capability to work with real-time data as well, which comes at high velocity and in high quantity within certain time interval. So for that purpose, structured streaming you can use to process this real-time data using Python language. Also, you can leverage the MLlib library, which gives us the capability to work with machine learning algorithms like the PageRank algorithm and so many other supervised machine learning approaches using the MLlib library. And you can also utilize Python language to work with MLlib library seamlessly. So all these high level APIs are already supported by Python, which gives us the kind of versatility to your architecture, and many of the developers right now are already migrated towards Python because of its rich set of libraries and the community support it has. And also Python is pretty readable, and if you write any script in Python, it will be easier for any beginner level developer as well. So that's why PySpark is so popular nowadays. So now let's talk about why we should use PySpark in the first place. The first one is easy to learn. So as you already know that PySpark is nothing but a high level API on top of Spark, which gives us the capability to work with Spark using Python. So as you already know, Python is known for its readability and ease of learn. So that will gives us the capability to work in any agile development, because let's say if you already have some workloads which are written in Python and you're using Pandas library, but as you already know that Pandas is not that much scalable horizontally and you cannot run it on a distributed set of cluster. So that's why we can leverage PySpark, because PySpark you can able to code in Python only, so you don't have to learn Scala from scratch to be able to transfer your workloads from Pandas to Apache Spark. So that's why that's a big advantage of using PySpark. The next one being the scalability. So as you already know that Apache Spark is a distributed set of clusters, so which means that it gives us the capability to manipulate our data and transform our data in a distributed manner. Distributed means your workload will be submitted across the cluster of several data nodes, which is working in parallel, and we will be having like resource manager to track all the resources which are available, which are occupied. So all this stuff will go under the hood of Apache Spark, which gives us the great scalability. So since it uses the commodity hardware, they are easily replaceable. So they are cheap, they are readily available. So that's why horizontal scalability is a big pro for handling big data. Then we got the speed. So since Apache Spark's architecture highlights its in-memory computation, it gives us the capability to process your data 100 times faster than Hadoop, since Hadoop uses the MapReduce, and MapReduce will rely on reading and writing the data from the local disk instead of getting the data in memory. So that's why PySpark wins the race in terms of speed with Hadoop. Then we got this versatility. So as you already know that Python is very user friendly language. Also it provides high level APIs to work with machine learning library, which is MLlib library, which gives us the capability to work with ML algorithms. Also we have the graphics support, which gives us the capability to work with graph computation, as well as the Spark streaming API. So it is a pretty versatile tool for every data engineer, data analyst, as well as the data scientist, because it gives us so many high level APIs and rich set of libraries, and they are like widely supported, which is our next point. It has a great community support just like Python, and the libraries are enhanced day by day, and due to this strong community support, PySpark is a great choice for every data driven organization. Now let's talk about the architecture of PySpark. So PySpark has a similar architecture of what we have discussed in the initial Apache Spark lecture. So I'll not take much time. We got the driver program. So driver program means it runs the main function and defines one or more RDDs on your cluster. RDDs also it defines the data frame or data sets as well. Then we got the Spark context. So the Spark context is nothing but the object that will coordinate task and maintains the state and connection of the Spark cluster. So Spark cluster means it will have the worker nodes as well as the data nodes. Then we got a cluster manager. So as the name suggests, it is responsible for monitoring all the resources as well as a resource allocation process and managing the whole cluster. And it gets the state of all the applications which are running on the cluster. Then we got the executor. So executor program is nothing but a separate JVM processes that runs on the worker nodes. So this executor program is installed on all the worker nodes across the cluster, which does all the groundworks and processes the data in parallelly across this cluster. So we got the task as well. So task is nothing but you can call it as a smallest unit of work. So let's say if you are handling like a gigabyte of file and you want to process it and apply some transformation on top of it to get the required output. So basically this task will be converted into smaller chunks of units, and this smaller chunks of tasks are then distributed across the cluster on this worker nodes to get executed and get the result back in an aggregated way to the driver. So this is how Spark architecture works under the hood. Now let's talk about the features. So features, as you already know, we got the RDD, which is the Spark Core API, which is nothing but represents the data structure in PySpark. Then we got the data frames, which is popular nowadays, and I think you should use data frames over the RDDs. So it's nothing but the abstraction which is built on top of the RDDs, and they are like way more optimized using the Catalyst optimizer. So data frames nothing but creates a structured data frame, or you can say a table, which is nothing but consist of rows and columns and have some schema assigned to it. Then we have the MLlib, which gives us the capability to run machine learning algorithms on top of your data. Then we have the graphics for graph computation in your PySpark application, and we have the Spark streaming, which enables you to process the real-time data analytics. To process the real-time data streams using the same programming model as you have seen in the batch processing mode. So these are nothing but some of the basic features of Apache Spark. So I hope you really understood what is Apache PySpark in detail. Let's talk about how to use Apache Spark using Python in the next lecture.
So that's it for today. I'll see you in the next lecture.